Hello, my name is Leonid Shekhanovsky, and this, my channel Brave Stories. Today, I would like to present a strategic briefing on the Ukrainian Adaptive Air Defense Experience, commonly referred to as the FrankenSAM model, and evaluate what elements of this approach may be relevant for air defense planning in the Gulf region. Modern warfare has clearly demonstrated that control of the air domain remains a decisive factor in operational success. Without effective air denial capability, ground maneuver becomes increasingly constrained. However, contemporary air defense challenges are no longer defined solely by traditional aircraft threats. They are increasingly shaped by cruise missiles and unmanned aerial systems deployed in saturation patterns. It is important to emphasize that the Ukrainian operational experience has been primarily associated with defense against cruise missiles and drone systems. Ballistic missile interception has played a role, but in comparative terms, it has not been the dominant operational feature. The pressure has come largely from repeated waves of relatively lower-cost aerial threats designed to exhaust interceptor inventories. Under these conditions, Ukraine began implementing what can be described as adaptive integration architecture rather than complete system replacement. The concept, informally labeled FrankenSAM, refers to the modernization of legacy Soviet-designed air defense systems through integration with Western interceptor missiles and updated electronics. Two key legacy systems associated with this approach are the BUKM-1 medium-range surface-to-air missile system and the S-300PMU long-range air defense system. Instead of discarding these platforms, the focus shifted toward extending their operational utility. One of the central integration elements involved the RIM-7C Sparrow missile. Historically, more than 100,000 early variant RIM-7 missiles were produced. Many of these missiles are no longer frontline assets in modern naval service, but remain in storage. This creates a potential reserve resource for adaptation. The RIM-7 weighs approximately 230 kilograms, significantly lighter than many older Soviet interceptors. Reduced missile mass improves launcher mobility and reduces mechanical stress on legacy platforms. More importantly, guidance logic similarities between semi-active radar homing systems made technical integration conceptually feasible. Another important clarification concerns operational focus. Ukrainian optimization efforts were centered mainly on intercepting cruise missiles and unmanned aerial vehicles. These targets typically operate at low or medium altitude and present different engagement dynamics compared to ballistic threats. There were also experimental adaptations of air-to-air missile stockpiles for ground-based launch applications. One example discussed in open sources is the R-73 short-range air-to-air missile. While originally designed for fighter aircraft, testing ground launch configurations demonstrated the flexibility of legacy missile inventories under constrained supply conditions. Beyond hardware integration, one of the most significant improvements involved trajectory optimization software. Traditional interception often follows a direct path toward the predicted target position. However, updated engagement logic allows missiles to climb into higher altitude layers where air density is lower. At altitudes above approximately 5 kilometers, aerodynamic drag decreases significantly. This reduction can extend effective engagement range by roughly 30 to 50%, depending on atmospheric and target conditions. For Sea Sparrow derivatives, reported engagement distances increased from roughly 20 kilometers to approximately 30 kilometers using trajectory optimization techniques. This illustrates that software and control logic can meaningfully enhance performance without redesigning the entire missile. Another area of discussion involves potential radar and interceptor cross-integration. Surface radar elements of the S-300PMU family may theoretically coordinate with interceptors, such as the Patriot PAC-2 missile. The PAC-2 class is optimized primarily for aircraft and high-altitude target interception, with reported engagement envelopes reaching approximately 160 kilometers under favorable conditions. The significance of this approach is not platform substitution, but layered networking. Legacy radar infrastructure can contribute to an expanded interception envelope when integrated into a broader command architecture. From a Middle East defense planning perspective, several structural parallels are worth noting. Gulf states operate sophisticated air defense systems but face similar strategic challenges: protection of energy infrastructure, dense urban centers, aviation hubs, and critical national assets. The increasing availability of cruise missile and drone technologies globally raises the importance of cost-efficient, layered interception. The Ukrainian experience demonstrates three key principles. First, legacy systems do not automatically become obsolete if integration pathways are technically feasible. Second, missile inventory sustainability is as important as peak interceptor performance. Third, software-driven engagement optimization can significantly expand effective coverage without proportional cost increases. For Gulf states such as the UAE, Saudi Arabia, Qatar, Bahrain, Kuwait, and Jordan, adaptive modernization concepts may offer complementary layers rather than replacements for existing systems. Compact geography in some states favors dense, layered coverage. Large territorial states require distributed radar networking and flexible launcher mobility. In both cases, extending the life cycle of existing assets can improve resilience under saturation scenarios. Global air defense doctrine is increasingly moving toward sensor fusion, distributed command coordination, and intelligent interceptor allocation. Platform-centric superiority is gradually being replaced by network-centric survivability. The Ukrainian FrankenSAM experience should not be viewed as a universal template. It is context-specific. However, it demonstrates how engineering adaptation under sustained operational pressure can maintain defensive capability even when procurement pipelines are constrained. For Middle East defense planners, the broader lesson may not be about a specific missile or system. It is about architectural flexibility, integration readiness, and layered sustainability. Thank you for your attention. If you found this briefing valuable, please subscribe to the channel, like this video, and leave a comment sharing your perspective on adaptive air defense modernization.